All right, so we learned about how to deal with composite functions when the inner function was linear. And that rule that we learned yesterday, the 1 over a times the antiderivative of ax plus b, that is actually a common thing that happens as a result of a process we called U substitution. Now that's about the only pattern we get, okay? The rest, we're actually going to have to use this whole method. But I want to start talking about this method a little bit and then recognizing how it applies to what we were doing in the previous lesson, okay, with the linear functions. Then we'll expand it to include functions that aren't linear, okay? So this is kind of equivalent to a chain rule. It's the closest thing we get to a chain rule for integration. Like we said already, there's no chain rule or product rule or quotient rule. So this is the best we've got. Now, you'll notice what I have here is I'm saying that u is a function of x. So u, this is a composite function, f of u. Okay? F of u, we have this inner function inside the function. And what this is saying is that if we are taking the integral with respect to x, and inside of here we have f of u times du dx, notice what we can do. We can actually cancel out the dx's, and we're doing the integral of f of u du. Okay, so we have actually substituted out all of the x's, and we only have u's left over. Okay? Now, it can be helpful rather than just having u's to see it as a g of x. Okay, so that's why I've done this, because you can kind of see the composite function a little bit easier. Okay? So we have this g of x. The derivative of that is g prime. Okay? Now look at this. This you have to really pay close attention to. This du dx equals g prime of x. This is du divided by dx, right? So I'm going to multiply both sides by a dx. And guess what? The du equals g prime of x dx. Okay? Does everyone understand what I did right here?
I don't really know.
I mean,
Okay.
I get the math, but like, what's du?
Du is a differential. It's just like we have dx, we have du. It's telling us what we're going to integrate with respect to. Okay? But we saw those also when we took derivatives. We had dy over dx, du over dx. Okay? In this case, what I'm doing is I'm starting with this function, u equals some function of x, g of x. Okay? I take the derivative of u with respect to x, du dx. Well, I know that if I take the derivative of g of x, it's g prime of x, right? Okay, so du dx is g prime of x. Now I'm multiplying both sides by the dx. So I just have du by itself equals g prime of x dx. Okay?
So,
Okay?
yeah. Because it's just going to be a formula, so I'm just going to look at, if what you're giving me, I'm just going to turn it into g prime of x dx, right? Like, do you get what I'm saying? Like,
that's...
you're just showing us the breakdown of how you got to the formula, so we're just going to plug it in like that.
Well, that's the thing. For the formula from the previous lesson, yes, so that will end up looking the same every time. What makes this challenging is that every function is unique. So there's not just going to be some formula you can memorize. You got to know this whole process here. Okay?
So we have really
Now, I can now substitute here. If I have some function, and let me write the original here, okay? I have some function where I have something to a power, okay? G of x, I have some u to the n power, or r, okay? But I'm integrating with respect to x, okay? So I have some function, g of x, I'm raising that to the r power, okay? If I have g prime of x dx,
Why are we raising the power of it?
That's just a function.
I'm giving you a function here,
Oh,
okay? If I have something in this format here, where I have an inner function raised to a power times its derivative, all inside the integral, I can rewrite this as the integral of u to the r du. Notice this whole thing gets replaced by du.
So du is just like the dx on the end of the integral. It's a-
It is.
no pl-
It's a differential, yeah.
It just says this is where the end of the integral is now.
Yes,
That's respect to you.
yes.
Okay.
So, I know this is a little bit hard to follow. Let me use an example to actually illustrate this, okay? So here I have something that we worked with in the previous lesson. And actually, you guys all know how to just write down the answer at this point because the inside is linear, right? The u is a 2x minus 1. Okay? U is 2x minus 1. Alright? What was the derivative of this?
2.
It's 2. Okay? So now, if I multiply both sides of the equation by dx, I have du equals a 2 dx, right?
Okay.
If you multiply what by what?
Everything on both sides by dx, then you get.
Oh,
2
I've done
dx.
this.
Okay?
I'm sorry.
Yeah, those of you who took
Multiply dx.
calc
I'm just
before
like-
you've done this.
Before you did this, it looked like mumbo jumbo.
Yeah. Okay?
dx is right there, so you multiply both sides, they cancel out dx.
It's- you'll
on one
get
side,
it,
it's
fine.
2 dx on the other.
So, using the rule, because it's linear, I automatically know this, okay? Check this out, guys. We have,
Okay.
I have 2 something cubed. What's the integral of 2 something cubed?
1/3, or
Got you.
1/3, 2, 1/3.
1/4,
Over 4.
something to the 4th.
To the d.
Harry? Okay, so we have 2 something to the 4th over 4, but what were we told to do with this? Also, because we had a linear function inside,
You multiply by
The 1
1 over
over
2.
a.
we multiply by the 1 over a, the 1/2 in this case, okay? And notice what that ends up giving us, the 2's cancel out, and we have 2x minus 1 to the 4th over 4
Can you explain to me why we did
plus c.
1 over half or 1 over 2 again?
That was the rule we learned in the previous lesson,
Oh, right.
that 1 over a times.
Oh, yeah, yeah.
What I'm showing you now is the entire process, because that shows us where that 1 over a comes from. And it also, once you know the entire process, that allows us to do functions where the inner function is not linear. Okay? So stay with me here. So at this point, notice what we can do. If I go back here, I'm going to rewrite this a little bit as 2x minus 1 cubed times 2 dx. Okay? Now the reason why I did that is because notice this 2x minus 1 is the u, right?
Yeah.
So this is the integral of u to the 3rd.
Okay.
Okay? You'll also notice that over here we recognize that du equals 2 dx. Well, guess what? Here's a 2 dx. So I'm going to replace that with a du.
Okay.
Now, what's the integral of u to the 3rd du?
1/4 u to the 4th.
1/4 u to the 4th. Okay? So this is 1/4 u to the 4th, which, what do you know? That equals 2x minus 1 to the 4th over 4. Okay? I plug back in the 2x minus 1 for my final answer. Okay? So that 1 over a thing, is what got rid of that 2. Okay? The reason why we do that is because through this process, that 2 ends up getting substituted out. And that happens every time we have an a in there. It ends up getting substituted out when we replace it with the du. So we multiply by a 1 over a to get rid of it. Yeah.
Did you solve it 2 different ways, or did you just like put the answer first and then?
We solved it the first way using the formula that we looked at for linear inner functions.
Right.
So if you have a linear inner function, you don't need to go through this whole process. Okay? If it's a linear inner function. The reason why I'm starting here though is 1, so you understand the formula, and 2, so you know the process that we can apply it to other functions. Okay? So let's look at kind of a process for this. First of all, recognize a function inside what you're trying to integrate. In other words, identify the u. So here we're going to do the integral. We're not going to worry about the 2 and the 5 right
I
now.
was gonna say, we've never done that before.
We haven't done those yet. Okay? So here I have the integral of the square root of x plus 3 dx. Okay? So what is the inner function here?
X plus 3.
X plus 3. Okay, so I recognize the inner function. Then, you want to get the rest of what's inside the integral to equal the derivative of the function. In other words, get that g prime of x dx. Okay, well let's figure out what that actually equals. Du dx equals 1. And then if I multiply both sides of the equation by the dx, I have a 1 dx, right? Okay. Du dx equals 1. And then I multiply both sides by the dx, and I get du equal to 1 dx.
Can I get some time whenever you use like the derivative of the
Yeah. Yeah. Okay. I'm doing the whole process here, though, not using the formula. Okay. We're starting simple here. Okay. We're starting with the easy ones that you could use the formula for. Okay. So, at this point, I need to recognize, hey, this already has an understood 1 in front of it. So I already have everything I need for my du. Okay? Then I need to rewrite the integral in terms of u. Okay, so I'm rewriting this integral as the integral of the square root of u du. Okay, the 1 dx became a du. The x plus 3 became the u. Okay? Now I have something that we have an antiderivative for. What's the antiderivative of something to the 1/2 power?
2/3 to the 3 halves.
Yeah, 2/3 u to the 3 halves. Okay? Did our problem ask us for a derivative in terms of u, though?
No, it's applied view back in.
No, we wanted the derivative with respect to x, so we plug back in the x plus 3. So it's 2/3 x plus 3 to the 3 halves, and now we'll throw on the plus c.
Yeah.
Okay? So that's our process. Identify the inner function, figure out what du would equal, and substitute that in. Then you can integrate and then substitute back in what u equaled to get your final answer. Okay. Let's do another one that doesn't have a linear inner function. Okay? So here we have the integral of x squared plus 3x to the fourth times 2x plus 3 dx. Okay? So what would we call our inner function in this case?
X squared plus 3x.
Okay, x squared plus 3x. Alright, so I'm going to make u equal the x squared plus 3x.
Why isn't it 2x plus 3?
Well, you could try that. That's the thing, you try that, but the reason why we picked this one is because notice it's inside something to the fourth.
Yeah.
So I can see it's an inner function. Okay? So now, take a look at this. If I do du dx, what does du dx equal?
2x plus 3.
2x plus 3. Okay? So now, check this out. Du dx is 2x plus 3, so that means du is 2x plus 3 times the dx. Does everyone follow what I did right there?
Yes.
Okay? So now, check this out. Du is 2x plus 3 dx.
I remember this.
What do you notice? The rest of this here was set up really nicely for us. That whole thing I can take away and replace with the du.
Is that how it should normally be? Or that's just like,
Well,
That's
you
typically how we'll get it, at least for SL, that's typically how it will end up being set up. Or we will look at ones where you have to do a little bit of manipulation to get it to work out.
But you just multiply
Wait,
this,
wait, 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 what's that?
like what do you have to do? What do you
Where you have to do what?
What do you have to do to manipulate it? Like,
We'll get there. We'll get there.
It's simple.
Okay, so notice here, this right here was our u, the x squared plus 3x, so now I have u to the fourth du that I'm taking the integral of. Okay, what's the integral of u to the fourth?
1 over 4 is u to the 4th.
Yeah, 1/5 u to the fifth, or u to the fifth over 5. Okay? I don't want my answer in terms of u, so I substitute back in the u equaled an x squared plus 3x. So that is to the fifth
Plus.
over 5 plus c. Okay?
Yes.
So,
yay,
any questions here?
we love anti-derivatives.
Can we drop out of
Okay.
school?
So.
I mean, legally you can't.
Okay, so one last one here. What do we do when part of u is missing? Okay? The u in this case is going to be the x cubed plus 5. The du is going to be what?
3x squared.
3x squared dx, right? The problem here is I need a 3x squared dx. All I have is an x squared dx.
So you multiply by 3 and then 1/2 on the outside.
So I can multiply by a 3 here as long as I counter that, because I'm not allowed to just multiply by 3. I can multiply by 1 though. So if I multiply by 1, I have to multiply by a 3 over 3, or a multiply by 3 and a multiply by 1/3. But notice I'm putting the 1/3 on the outside. Okay? I've just multiplied by 1, but now what that allows us to do is I have 1/3 times the integral. This whole thing, the 3x squared dx, gets replaced with the du. And we now have a 1 over the square root of u. Okay?
So it's just 1 over x to the 3rd plus 5
Okay, so now we integrate something to the, yeah, so we're doing the whole thing, at the very end we'll multiply by a 1/3, okay? But we have u to the negative 1/2 power, so that's u to the positive 1/2 times 2, because it's divided by a half. And now I can go ahead and substitute back in the x cubed plus 5, okay? And that's going to be 2/3 x cubed plus 5, and then throw on your plus c. So if you don't have the entire part of u, if you're just missing a constant, you can multiply by the constant on the inside and its reciprocal on the outside, and that'll give you what you need. Okay?
Yeah.
Alright, try the practice for tomorrow. We'll see you later.